This is your video for 4-7 inverse linear functions on page 263 of your textbook. Okay, so inverse functions or inverse relations are essentially what we're doing is we're switching the x and the y. So in an ordered pair, if the x is -3 and the y is -16, your inverse becomes -16, -3. So you just switched the x and the y coordinates. You would do the same thing in a table. So if this x value is -4 and the y value is -13, when you find the inverse, your x would be -13 and your y would be -4. So these are pretty easy with the ordered pairs and the tables and all of that. It's a little bit more difficult when you have an equation. So we're just going to do some of the equation ones. But if you look right here at the key concept, it actually has a step process for you. So if you'll follow these steps, then you can solve the equation. If the equation is written in function notation, which means this f of x is here instead of y. But f of x is the same thing as y. So anytime you see an f of x, you can exchange it with a y. Those are the same thing. Okay, so let's look at some of these in the book. All right, so number 9 in the book says it has a lot of ordered pairs, and it says to find the inverse of each relation. So all you would need to do here is write -49, -4. So see, we switched the two, the x and the y value. And then the next ordered pair, same thing, except this one is 35/8. Then the next one would be -28, -1. And the last one, 7/4. Okay, so this is the inverse of this one. This one, same thing. You would just flip around the x and the y. So when you write it, you'll do another table. And instead of an x of -8, you would put an x of -36.4 and a y of -8 all through the column. Okay, these say graph the inverse of each relation. So when we're graphing the inverse, what we need to do is, you can do it one of two ways. You can either find the equation for the line and solve after you've switched the x and the y, or easier than that, if they only want the graph and not the equation, is to pick points and switch the x and the y. So in this case, this graph goes through 3, 0, and it also goes through 0, -1, and it goes through -1, 2, 3, and -2, -3, -2. All right, so the inverse function will be at 0, 3, -1, 0, and -2, -3. And so if we were to graph that, let's just go ahead and graph that over here. This is our y-axis and our x-axis, remember? And so our ordered pairs on the other page were 0, 3, -1, 0, and -2, -3. Okay, so all we would need to do is put 0, 3, -1, 0, and -2, -3. As you can see, these also form a line. Okay, so if I were to graph it on the same axis, I would put 1, 2, 3. Let's do it in red so that you can see it a little better. So I have 0, 3. I have -1, 0. And I have -2, 1, 2, 3, -3. Okay, so I can say that f of x is the blue one, and the inverse of f of x is the other one. So I would write f, -1, and then an x. So the -1 is not an exponent. This is just saying that it's the inverse of f of x. So my original is f of x, and my new one, the inverse, is f of negative 1 of x. Okay, so this is how we would graph the inverse. Just swap the ordered pairs, the x and the y. Okay, and then some of them have equations. So for example, let's go ahead and do number 15. Number 15 says f of x equals 17 minus 1 over 3x. Okay, so when we're solving or finding the inverse function, remember we're switching the x and the y. This one doesn't have a y, so our first step is to replace the f of x with y. Okay, so instead of f of x, I'm going to write y equals 17 minus 1/3 x. After that, what I need to do is solve for y. Oh, I'm sorry. Not solve for y. Then we have to replace or switch x and y. So where the y is, I'm going to switch it and make it an x. So now my equation says x equals 17 minus 1/3 y. Okay, at this point now I'm going to solve for y. Okay, so the y is here, which means I want this by itself. So I need to move the 17. I'm going to subtract 17. So I have x minus 17 equals negative 1/3 y. Okay. Now here, remember to get rid of a fraction that is being multiplied. We multiply by the reciprocal. So I'm going to multiply by negative 3 over 1. And on the other side, you have to multiply the whole thing by negative 3 over 1. Okay, so these kind of just cancel out, equal 1. So I have y equals negative 3 divided by 1 is the same thing as negative 3. So let's just go ahead and write negative 3 instead of negative 3 divided by 1. And now I can distribute. Negative 3x and positive 17 multiplied by 3 is 51. So I have plus 51. Okay, and so this would be my final answer. Y equals negative 3x plus 51. Now, I don't mind, I don't care if you keep it without distributing. So I would count this one correct also because it's before we distributed and it's still solved for y. So either one of these would work for me. Okay, and then lastly, I want to do number 32 on your book. It says, this one's a bit tricky, but I like that it makes you think about it a little bit more than some of the other ones. And so this one would be something that I would expect to be seen on one of the Ministry of Education tests. So this one says the slope of f of x is 7. So this is my original equation, f of x. And then the graph of the inverse contains the point 13, 1. Okay, so on this one we know that if the inverse point is 13, 1, the original one was the flip of the x and the y. So the original one goes through the point 113. So there's a few things that you have to know in this problem. First, you have to recognize that if they give you an inverse point, the original would be the flip. But then we're going to have to do more because that's not all they're asking. They're also asking for an equation of the inverse function. So we have to find the regular function first, and we can use this point and write the equation in point slope form. So let's see. if my equation has a slope of 7 and goes through 113, my point slope form is y minus 13 equals 7 times x minus 1. We remember that this is our y1, and our x1, and then the slope goes in front in point slope form. Okay, so we don't want the equation for the regular one. That's what this is. What we want is the equation for the inverse function. So you can switch the two right now, or you can solve for y and then switch. I'm going to go ahead and switch them right now. So I have x minus 13 equals 7 times y minus 1. Okay, so I need to solve for y again. I'm going to go ahead and distribute here, because if I don't, I'm going to end up with fractions that I don't really want to work with. So 7y minus 7. You're going to have fractions either way, but it's a little bit easier if you go ahead and distribute first, I think, on this particular question. Okay, so since I want the y alone, I'm going to add 7. And I get x minus 6 equals 7y. And then our last step is to divide by 7. Okay, so I should get y equals x over 7 is the same thing as 1/7 x, so that's how I'm going to write it. You could write it x over 7. It doesn't matter actually which way, but I can see that the slope here is 1/7, and that's a little bit easier for me. And then minus 6 over 7 would be my final answer here. So this is the equation. Oh, I'm sorry, we also have to replace it. This is the equation for the inverse, so we're going to write f of negative 1x equals, or the inverse of x equals 1/7 x minus 6 over 7. So this one is actually the final equation. Okay, that's it.